Okay, so now we're going to talk about conversions, and it says hint. Put what you want to get rid of on the bottom of the fraction so you can play Miss Guidry's favorite game, which is known as Slashy Washy. So, really quick, I just want to kind of explain a little bit. So you know that every quadrant is worth 90 degrees, and in a whole circle there's 360 degrees. And it says to find theta, we're going to take the arc length and divide by the radius, which was on the other page. Well, if I want to find theta for the whole circle, this whole circle, let's talk about a circle with a radius of 1. So I have a circle, and its radius is 1 all the way around the circle. Well, its arc length, right here, is known as its circumference. So circumference of a circle is 2 pi r over r from this formula right here. So these r's are going to cancel out, so theta equals 2 pi. So that means that for any circle there are 2 pi radians. Again, if we don't label it, it's implied that it's radians, but if you want to write radians, you can. There are 2 pi radians in a circle, so I just want to do a little bit of math real quick. 360 degrees in a circle, 2 pi radians in a circle, those are both equivalent. We can reduce this because of the 2, so 180 over pi. Make sure you put the degree symbol. So if you want to go from radians to degrees, whatever you want to cancel out goes in the bottom. So if I want to go from radians to degrees, I want to get rid of the radians. So that means degrees goes in the top and the radian goes in the bottom. Please note that pi doesn't mean it's a radian. The pi is from the circumference formula. Degrees to radians, it's the exact same conversion, only we're going to put the radians on top and put the 180 degrees in the bottom. Revolutions are another way we talk about going around a circle. Well, one revolution is like one full circle, or one full trip around the circle, or one full circle. If you've only gone half a revolution, then you've only gone half a circle. So if you have 1/6 of the revolution, how far of the circle have you gone in degrees? Well, in a circle there are 360 degrees. So if I want to go 1/6 of the circle, I'm going to multiply that by 1/6. So I've gone 60 degrees. And now I can take this degrees and I can use it to convert to radians. 60 degrees times, I want to get rid of degrees. So I'm going to put the pi on the top and the 180 in the bottom. 60 over 180 reduces to 1 over 3, so I have pi over 3 radians. You also could have found the radians by saying, okay, the whole circle we just talked about up here has 2 pi radians in a whole circle. 2 pi times 1/6 is going to get me pi over 3 radians. Okay, to find arc length. For a circle of radius r, a central angle theta intercepts an arc of length s is given by this formula right here. And this formula should look very familiar because we just talked about it. Theta equaled s over r was the definition of a radian, and all we've done here is multiply the r over, so r theta equals s. And then make a note, highlight it, something. This theta, by definition, has to be in radians. So it says that a circle has a radius of 4 inches. Find the arc that is intersected by a central angle of 240 degrees. So there's 240 degrees. That's this thing right here. And it says that my radius is 4 inches. And so I'm looking to see how long this piece is. Well, first things first. Theta has to be in radians. So I'm going to take my 240 degrees. I'm going to multiply by pi over 180. And so you can do the 240 over 180, and it's going to reduce to 24 over 8, which then reduces to 4 pi over 3. So now that's in radians. So if I want to find my arc length s, it's going to be equal to my radius, which is 4 inches, times 4 pi over 3. So my arc length is going to be 16 pi over 3 inches long. So that's how long this arc is if I were to lay it flat and measure it. Make sure you know this formula for your test because you're not going to be given it. Final set of formulas on this page are the area of a sector of a circle. Okay, so again, this theta has to be in radians, but area is going to be equal to 1/2 r squared theta. So I'm going to make a pie that has a diameter of 10 inches. So here's my pie. My diameter is 10 inches, which means that my radius right here is going to be 5 inches. And I'm going to share this pie with my mom and my dad. So we're going to divide the pie into 3 pieces. And it says that every person's going to get an equal piece. Find the area of each piece. So I want to know what the area of each piece is. Well, the whole circle is 360, but I don't want to talk about degrees. I want to do it in radians. So the whole circle is 2 pi, which means every one of these angles right here is 2 pi over 3 because there's 3 of them. The whole thing's 2 pi divided by 3, 2 pi over 3. So now I can use my little formula. Area equals 0.5. My radius is 5 squared times 2 pi over 3. Just grab my calculator. And I'm going to type 0.5 times 25 times 4 over 3. And if you want, let's multiply the pi in. So 0.5 times 25 times 4 pi over 3. So my area is approximately 52.3. Usually we run to 3 decimal places, but as you can see, this 9 is going to round up that 9. So 52.36 inches squared, because it was area, and these radii had inches. So the area of each piece is 52.36 inches squared. Go back to Edmodo, and there'll be one more video for you to watch.